Hello, welcome to section 3, Advanced Concepts in C++. In this section, we are going to learn about templates, namespaces, exception handling, C++ preprocessor, function pointer, and finally, there will be an exercise that will cover whatever we learned in these 5 videos. In this first video in Advanced Concepts in C++, we are going to cover generic programming using template. So what is a template? Before we go and understand the template, so let's understand the fact that C++ is a strongly typed language. It requires all data types clearly defined before compilation. Now, in many cases, we encounter a situation where we have an algorithm, but the same algorithm can be used with different data types. So as the C++ is a strongly typed language, so the implementation must be made in all those data types. But that is a little clumsy. So what we can do is you can use templates to create a generic framework of that algorithm with an imaginary type, and then the user can decide which data type to be used with that algorithm framework or the generic code of that algorithm. So let's understand this concept using a sample code. So here we have our basic console program. And first thing we are going to do is we are going to add one function template. So basically it's a function which contains an implementation of an algorithm, and the type that we'll be using is an imaginary type. So let's put a comment here. Now to write a template, we must use a keyword template. Then in between the less than and greater than sign, we must type type name and T. Now here type name indicates to the compiler that there will be an imaginary type, and which we will call as T after this line, and we'll be using it. So, and we can now continue with the definition. Now the way we do it is just go to the next line just for readability purpose. So then we are going to define a function as if it is a normal function. So the return type we must define first, and in this case the return type can be void. Then we need to specify the function name. So in our case we are going to write it as swap with the capital S, so that there is no clash with any inbuilt function. So the first thing, there are two inputs we need, basically two numbers which will be swapped into one another without losing the actual content of those variables. So the first thing input we need is a variable which is of the imaginary data type. So in this case the variable name is A and the data type is T, which is an imaginary one. And we also need the second one. And now we can begin implementing the algorithm. The algorithm is very simple. We need another variable of the same data type. So our imaginary data type is T, and we are going to create a local variable which is C. So the first step is store the value of B into C. Next, we are going to store value of A into B. And finally, we are going to store the value of B into A. So to do that, the B is already stored into C, so we are just going to store whatever is stored, the value of C into A. So this will swap the values, and we don't need to return anything because these are all references which are non-const. So whatever changes we make here will be reflected back to the original variable. Now there is a slight difference between when we declare or define a normal function and a template function or a function template. So the template keyword indicates this is an generic implementation of an algorithm with an imaginary data type. So unless we use this code will not be compiled into a binary because there is no data type at all, and C++ without a clear data type cannot compile the code. So this kind of definition allows a generic implementation of an algorithm while fully complying with the strongly typed data requirement of C++. Now how to use this? So what we need to do is we have to write the function name here, and then within the less than and greater than sign we have to type in the data type that we want to use. So the thing is we have to, let's say we want to swap two integer numbers, and now we can input two integer numbers. So before that, what we do is we just define two integer numbers. So let's say call them A and B with a value 10 and 5, and we are going to simply supply those values into the swap function. And in the next line, we're going to print them to console. Let's build this and run it. And as we can see, we defined the variables as 10 and 5. Now it has been swapped successfully to 5 and 10. Now we said that this is a function template and this can work with any data type. So what if I change this to, let's say, double, and change it to, let's say, 10.2 and 5.7. Now in this case, all we need to do is call this function with a data type double, and that's it. We don't need to write another function which takes into two double values and then swaps them. In a way, we have implemented the algorithm and all we need is a data type at the time of usage. So let's build this, and if we run it, yes, so as you can see, the B value has now been swapped into A and A has been swapped into B. So this is how a function template works. So as you can see, this is more like a generic programming where we are defining the framework of an algorithm. We leave actual implementation at the time of compilation to the user. So far we have finished one function template. How about compound data type? Can that be templatized? Yes, that can be templatized. So let's build a class template here. To do the class template, let's consider the case of an array where we are doing the bound checking, and we will be able to insert particular value to a particular element of that array and also retrieve that value. And now this array can be generic. This can be an array of characters, this can be an array of integers, or be an array of double, or even any other data type. So again, to do that, we will begin with the keyword template, and we can use type name. So the imaginary type is D. Next, we are going to define the class, and we're going to call it an class array. So we can create data type, we'll store the elements of the array, and let's call it is an pointer to that imaginary data type, and we call it array, ARR in short. So now we have to create a couple of public interfaces, so that this data can be managed and used properly. So the first function we should create is the constructor function, and let's put a data type called size D, which is nothing but an unsigned integer, and we will call it size equals to, or let's put it as S equals to 10. So if there is no size is given, it will be assumed as a 10, and if a size is given, then it will be taken as a size. So all we need to do is we have to use the new operator to allocate some memory. So we'll go with this, and we are done. So we have created an array of an imaginary data type T, and which has a size S. Let's also build the destructor function here. Doesn't take any input, and all it does is safely deletes an array of which has the imaginary data type. So this will free up the memory. So now we want to implement two functions here. One is called the set, another will be called get. So let's create the code for first function, which is set. So what we are going to do is we need two inputs here. One is the index number, and the second one is the data itself. So what we need is a reference to that imaginary type, and we will call it input input. So now what we need to do is just do a little bit of, we are not going to do any bound checking, which is assuming just to keep our code simple. So we are going to simply put the data to proper index. Now mind it that this is highly unsafe, because if the index is more than the array size, it will overflow. The actual code should also add some overflow checking, bounds checking. Now what I'm trying to just simplify, keep the code pretty simple and within, keep it short. So it's doing like that, but in real life you need to do the bound checking. Now we need to get the values. So all we need to do is we must get the value which is of that imaginary type, and we'll call it get. And in this case we need an index. Okay, and all we need is So we are pretty much done, although it's a little unsafe, but we are ready to go. So let's delete this code because we are not going to use it now. And because again, as I said earlier, when we write a template, it doesn't get converted into binary when we compile it. So now what we need to do is called instantiation. So all we need to do is create an object of array which will store integer data type, and we will call that object as int array. And int array, let's set the first element as 10 and print first element of int array to the console. So if we build this, okay, because this is defined as a reference, so what we can do is either define a variable here, or we can change this to a simple variable, just copy one, and this will work. So done. We are ready with our class, and let's run it. So we have created an object which is an array object of an integer. We have set of that first element to 10, and we have successfully retrieved that value. Now, as we have written this template form, if we want to use this for as a double, for let's say to store a couple of double values or character values, so let's do this interesting task. Let's save some character values. So what we are going to do is we are going to create an array of characters. So we'll call it char array. Keep a space here. So we have an array of characters which will store a number of characters. As we are not giving them any numbers, it is creating an array of a default size 10. So let's give a number here so that it creates something. So let's put a slightly bigger number, 256. So now the array will be 256 characters long. And then the thing is simple. All we need to do is set, we have to give them the index, and we have to give a value of that particular data type. So let's call it h. Okay, and let's repeat this code and I just want to print high. So I'm just going to copy this, and as we know that we need to create null terminated string, and we are going to print this. Although it's an ugly form of string, I just want to show that this is how the template function works. So now retrieve all those values sequentially. So I want to retrieve the 0 one first, then the second one, and finally third one. Just finish it with an endline character. So we should now see hi and a null terminated character. So we should be printed as hi. Let's build this. And as you can see, we have created two objects. One is integer type and another one is character type. So in integer type, we have created an array, and we have set the second element if you start the index from 0, and then retrieve the same element. And we didn't do anything to the code. All we have done is instantiated another instance of a class which has character data type, and then we can set, first character is h, second character is I, and the third character is a null character. And when we print that, we a nice little I printed out on the console. Now I hope this has demonstrated the concept of generic programming, how we can use template to create function templates and also class template, and then we can use that, we can instantiate that particular template code using any generic data type. So in this video, we learned about the concept of generic programming using templates.